Hello, I'm going to show you today how we go about calibrating the Aerosensor. I'm all set up here. I've put in my parameters into Aerosensor. I'm using a calibration factor of 1.4 to start off with. So at the top of the setting menus, where it says aerodynamic calibration factor, I put in 1.4. I'm now going to go down this road, back again, and then repeat it. And each time I go out and back, Aerosensor is going to calculate a calibration factor for me, and then I can put that into my device. Okay, so I'll go out, I'll see you in a minute. Aerosensor will automatically start a lap when you go above approximately 25 kilometers an hour, and the lap will end when you drop back below about 22 kilometers an hour. It is best at the end of this straight to brake hard to ensure that the lap ends swiftly. Make sure you take at least 5 seconds turning around at either end of the out or back to make sure that the laps are properly separated. On page 9 of the ACS Connect IQ app, you'll see a list of all of your laps, and on the far right are the calibration factors. You can tell which of these are valid, as those are the ones with a non-zero CDA value. Take the average of all these calibration factors to get a new factor. Multiply your initial calibration factor in the Garmin by this new factor, and that is the true calibration factor for your current setup. What is the aero calibration factor? Well, as you can see from this CFD picture here of a typical bike, the flow starts slowing down as it approaches it. These are contours of wind speed. This sort of orange up here is the free stream speed, and as it goes towards a yellow and then towards a green, the flow is slowing down because of the presence of the bike. And because we have the Aerosensor here somewhere, the flow will be slower than the free stream. So we need to scale up the wind speed measurement to account for this. So long as you aren't making big changes to your body position or moving the Aerosensor on the bike, this value should be pretty constant. So we're going to explain this by using our Aerosensor out and back analysis tool in Excel. There are two sheets here. One is a control where we're going to load the data in from. There's also a channels sheet which explains all of the records in the fit file. We have record fields which are 1 row per second, lap fields which will be 1 row per lap showing the averages for each lap, and then session fields which have all of the Aerosensor settings in. So I'm going to go in here and load in 2 files. And for these fit files I've got one which is a baseline and then another one which is actually quite a different position of the Aerosensor on the bike. Doesn't matter exactly what we've done, this is just to show how we would account for that change in position. So I'm going to click on open, and that's going to open each fit file, import the data, and then try and match up the laps based on us doing out and backs. So in summary 1 here, I've got my baseline data. We don't need to worry too much about these other charts right now. What I'm most interested in is the aero cal. So up here, we've got this cal value here, which is the value that we had in Aerosensor when we started. I'd normally recommend that you start with a value of 1.4. Here we already knew roughly what value we should have. And then for each out and back, by assuming that there is no headwind at all, we can calculate an aero calibration factor, assuming that the wind speed is the same as the road. Of course, there's some wind, so you'll see that these values will be higher in one direction than the other. So here we have 1 row per lap, so out, back, out, back, out, back. So 3 out and backs in this fit file. And then in my out and back summary, I'm taking the average of those. And you can see the aero cal value here is the average of those, and we're pretty close to 1. Exactly 1 is what we would be after in an ideal world. The CDA for each lap already uses the calibration factor that we put into the Garmin, this value of 1.346 here. But we know that there's a slight difference to what we had before by just 1%. By taking the average of these 3 values, we can get an overall average for this run. Here it's 1.01, so we're just 1% out. Now, if I go to summary 2, this is quite a different position on the bike. So you'll see that when we do our out and backs, we're getting a value closer to 0.9. So you'll see here the average for all of those laps is 0.9. Now, this data is going to be saved into our summary. So we've got 1 row per run here. I'm just going to change the number of display decimal places. So we've got CDA, which is using our default value, and we've got the aero calibration factor. Now, there are 2 things that I need to do here. Firstly, I need to correct my CDA for the actual calibration factor. The nice thing about Aerosensor is we don't need to do a separate calibration run. We can post correct it. So what I'm going to do here is I'm going to do corrected CDA here, and I can divide my CDA value by the aero calibration factor. So that gives me a true value, and you can see that this CDA factor here is a little bit lower than the one that we recorded, and I can do the same there. So because we've got 0.9 here, this CDA is coming up a little bit. So again, we can see, I'll just increase the size of this so it's clearer for you. We can see that the values have changed by a fair bit. So the difference between these 2 positions is smaller, so it's a CDA difference of 0.019 than what we actually measured, 0.05. So this is what our result should be. So we can see that the run 2, this real CDA was just 0.019 lower than the baseline. Now, if I was going to carry on doing runs in this second configuration, I would need to put into the Aerosensor a corrected aerodynamic calibration factor. And I can calculate that if I type in here, true cal factor. I can calculate this by just multiplying the factor that I had in the unit by the aerocal that's calculated. That's because the aerocal and the CDA are already using those calibration factors that are in the device. So you can see that for the second configuration, we've got a value that's quite a bit lower. So what I would want to do is put this value back into the settings. Now, obviously, you're not going to have your laptop when you're out doing your testing. So what we'd recommend is that you go to page 9 on Aerosensor, and you'll be able to see the calibration factors for each lap. It's under a column called cal. So you will see these values here. And what you'd want to do is average all of them, multiply that by your original calibration factor, and put that back in the device. We realise this is not a smooth process, and we are working on an update which we should release next week, so that will be the first week of November, that will make this process easier for you. I hope that explains everything. The key takeaways are that if you're making big changes to your body position or the position of the device on the bike, it's important to look at that change in calibration factor and correct your CDA for it. If you have any questions, please don't hesitate to email us at support@aerosensor.tech, or also you can join our Discord forum. I can show it here. Drag this across. So on our Discord forum, anybody who's a member of the forum can create a new topic, and we always get back to you. We aim to get back to you within 24 hours. And the idea of this is that anybody can reply. You can discuss with other riders what their experience has been, and also anything that points towards us being able to do a better job, we'll take that on board and put that into our development plan.